Alright, so last class we briefly talked about isosceles triangles and their theorems. We used them in our proofs, but today we're going to be looking at how we can actually apply them to solving for unknown angles or unknown sides. Alright, so first off, what is an isosceles triangle? Make sure to your shoulder partner. Tell them what is an isosceles triangle. What's our definition? Alright, I heard two very important words. A triangle with what? Come on, guys, you just said it. Triangle with what? At least two congruent sides. Okay. So a triangle with at least two congruent sides. And it's extremely important that we know our vocab, so we're going to write it again. Triangle with at least two congruent sides. And again, we covered briefly our isosceles base angles theorem and converse of the isosceles base angles theorem last class. But we'll go ahead and rephrase it here. So we wrote on our theorems and postulates page the nice full long theorem. So isosceles base angles theorem, if two sides of the triangle are congruent, then the angles opposite those sides are congruent. Okay, so let's maybe kind of shorten it down, just give us a straightforward one. We've already written the full one on our theorems and postulates page. In an isosceles triangle, the base angles are congruent. In an isosceles triangle, the base angles are congruent. What does it mean to be isosceles again? Alright, come on. You guys just said it. What does it mean to be isosceles? Thank you. So we have two congruent sides. So when we say in an isosceles triangle, it means a triangle with two congruent sides. And the base angles are congruent. And we talked about the fact that the base angles are the angles opposite of those congruent sides. So I'm going to go and pull up for you the true full theorem. We're just kind of shortening it down here once it comes up. Alright, so we filled this in last class. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. Alright? So we're just simplifying it down in an isosceles triangle, the base angles are congruent. So here I have my two sides. So we have side BA is congruent to side BC. Then what else can we say? Ryan, help us out. What else can we say? Very good. We have angle C and angle A are congruent. Angle A is congruent to angle C. Very good. Alright, now our converse of the isosceles base angles theorem. Again, let's take a look at the long version of it. Oops. Our long version says, if two angles of a triangle are congruent, then the sides opposite those angles are congruent. Okay, now again, we know that we're talking about isosceles triangle here. And the sides opposite of those base angles are called the legs. So let's just go ahead and simplify down this theorem for us. If the base angles are congruent, then the legs are congruent. Okay, so again, we saw the long theorem, but we know base angles, so if our two angles are congruent, then the sides opposite, those are just our legs. So we can kind of also use this to know that it's an isosceles triangle. If we have those two base angles congruent, that means it's an isosceles because those sides opposite are congruent. Alright, so here we have given to us that angle A is congruent to angle C. So now we can go ahead and go backwards and say side BC is congruent to side BA. Pretty basic and straightforward. Again, what we were doing in the last class. Alright, and this corollary we've already talked about earlier. A triangle is equilateral if and only if it is equiangular. What type of statement is that then? Biconditional, good. So biconditional means that we can go both ways. If a triangle is equilateral, then it is equiangular. If a triangle is equiangular, then it is equilateral. Tell your shoulder partner real quick, what does that mean to be equiangular? You guys are all good with equilateral. Talk to your shoulder partner to be equiangular. Alright, what does equiangular mean again? Yeah, all the angles have the same measure, all the angles are here. Good. Okay. So we're going to pull this information together along with what we know before and solve for our unknown values here. Alright, so this first example says, what is the value of x? Alright, we can see this is an isosceles triangle. Isosceles base angles theorem says that these must be congruent. So this must also be x. Can x be a different value for these two angles? Can I have x equal 49 and x equal 51? No. X is the same value within the problem, right? Keep that in mind when you get your quiz back today. Alright, how many degrees are there within an isosceles triangle? 180. So I've got x plus 30 equals 180. Or 2x equals, subtract my 30, 150. So what does x equal? 75. It's 75. Not too sure. Now B is a little different in that we have the big overall triangle, but then we also have these two smaller triangles. So if I look here, my big overall triangle is isosceles. Would you agree with me there? Okay, we can see that we have the same congruent legs there. So then again, isosceles base angles theorem, our base angles must be congruent. So if this is 42 degrees, how much is this guy? 42 degrees. Now, they also told us that these are congruent. So if this is x, then this must also be x degrees. Alright, so let's go ahead and again for the big blue triangle here, we've got 42 and 42, so is that 84? And then we have x and x, which equal 180. Does anyone not see what I did just there? Okay, so let's go ahead and solve. Subtract 84. So we get 2x equals 100 minus 4, 96. And what do we get for x here? 48. Very good. Alright, they did not ask us for it, but what do you think is the measure of this angle here? 90. Very good. So we know then that we could take a look at this small angle, and we would have 48 and 42 gives me 90, which leaves that as 90. So that leads us kind of to an interesting property there with isosceles triangles. But we'll leave it at that. Okay, questions on this first page? Pretty basic, not too bad. Okay, let's take a look at the back side. Oh, how kind, approved. All right. You know what? I want you to go try this with your shoulder partner. Try this proof. They gave us that AE is congruent to DE, and AB is congruent to DC, and they want us to show that EB and EC are congruent. Okay, so go ahead. Actually, try this first on your own for about 2 minutes, and then I'll tell you to switch and work with your shoulder partner. Let's see how we do with it. right, go ahead and compare with your shoulder partner. Even if you're not finished, go ahead and work together. Compare what you've gotten so far, and then work together to finish it out. All right, so I have a new volunteers to write the first step to the proof up on the board. Go ahead, Ryan. Jumped on that opportunity. I'm just gonna have people come up and write the different steps, and we'll work through it, see if we agree, see if we need to adjust anything. No, just go and write one, and then write your. We'll know that part of an ST means statements. That clarified it for us. Thank you. Do we agree with our first statement? Are we good with this? And our reasons given. Alright, so Ryan got the easiest part. Who feels confident to go and write up the second step? Go ahead, Vincent. And don't be afraid to come up. We'll go over it and make adjustments as needed. Thank you. Alright, so we have angle A is congruent to angle D. Give me thumbs up if you agree with this, thumbs down if you're not so sure. Alright, I see a lot of agreement. And isosceles space angles theorem. Awesome. We have this big triangle. I'm going to highlight that there. This big triangle is an isosceles triangle, so you can say those space angles are here. Awesome. Alright, anyone feel confident for step 3? No one feels confident. Go ahead, at least come up. So we've got triangle EAB is congruent to triangle EDC. Go ahead and show me your thumbs again. Do you agree, disagree? Awesome. Very good. So we have side, angle, side on both of these. But those two triangles are congruent. Awesome. Okay. So now step 4. Who feels confident with step 4? Go ahead, Ryan. Come on up. Favorite reason, CPCTC. All right, do we agree with this? Yeah, we've got 2 sets of congruent triangles. So now I can say any of those corresponding pieces are congruent. Now we are specifically interested in these ones. So I can say that this is congruent to this. CPCTC. Awesome. What else could we say about triangle EBC?
The overlapping triangles are congruent.
Yes, I would go with that as well. So Swapnil said that we could say our overlapping triangles are congruent. Let's take a look at that. And that's good to keep in mind for if we are asked to identify congruent triangles. Because I had this was congruent, we now have that's congruent. We also have that angle's congruent. Would that by itself be enough though, the angle side side? No, that's a bad word, right? So we should not be using that bad word, and some of us wrote that on our quiz, which was not a good idea. But we now know that this, with that being congruent, this is reflexive, so we could say this whole thing is congruent as well. So we then would have side, 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 compared with this guy. Again, same thing there. Or you could have said side, angle, side with that. Good. Now, what do I know about, I've got too many colors going on here. What do we know about this triangle here? What can we say now about that one? Go ahead.
It's an isosceles.
Yeah, it's an isosceles triangle. So this proof could have asked us to go even further and show that angle EBC and ECB were congruent. That would have been an option. And it could have also asked us what no set for those overlapping triangles to be congruent. So we would have had to do it. So very good. All right. So we have the next chunk is just doing some practice with our isosceles triangles. Notice we have some overlapping triangles that can mess with us, as well as some equilaterals kind of mixed in there. So I'm going to have you partner up and work on these problems, and then we'll come back together and go over ones that we struggle with. So listen closely for your partner, and then I'll give you some time to work on that. Okay, I agree with 5. 6 looks good. 7 looks good. 8 is good. 9 is good. 10 is good. 1 was a little tricky, wasn't it? Good job there. 2 also looks good. That is 44 degrees. And good work on number 3. Okay, which ones do we need to see? Which ones are we still a little weary? This one, the last one. Your question mark. Alright, so let's take a look at this last one here. Okay, so we have a few different triangles happening. And again, just take it a piece at a time. I have this triangle here. What type of triangle is that? Isosceles. And so if I know this is 15 degrees, I know that these are going to have to be the same. So you can call that really whatever letter you want. I'm going to go ahead and just call it x. So I have 2x plus 15 equals 180. So subtract my 15, I get 2x equals 165. Divide by 2. I get x equals, that doesn't divide very nicely, does it?
No,
82.5. It's alright, 82.5. Alright, now what type of triangle do I have here?
Isosceles.
Isosceles once again. Now, we don't know any of these angle measures yet, so we'll just kind of hold on to that fact. Alright, and then what type of triangle do I have here?
Isosceles.
Isosceles. Okay, so it says M and N here. Okay, well, I don't know M. I don't know N, but what do I know? What can I use? I mean, they did. Okay, well, sorry, I don't want to give too much away. What else do I know? What else can I do? That's it.
The angle in the right corner equals 90 degrees.
Very good. We have it. This is 90 degrees. So even though they did not give me explicitly these angles, I can find them. So 90 minus 15. Do some old-fashioned subtraction here. 75 degrees. Do we agree with that? So 75 degrees for that one, which means this one is also 75 degrees. Which means I can find this little guy here. I'm going to call that class. All right, what's 75 and 75?
150.
Okay, so y plus 150 equals 180. So what does that leave for y? Just a mere 30 degrees. All right, so now I do know this piece, which allows me to find m. How do I use that to find m? What do I know about those three? What did Thomas? Yeah, these three angles add up to be 180 degrees. All right, so I have m plus my y was 30, plus my x one that I found was 82.5. I'll add that to be 180. We simplify and solve, and that's how we get our n is 67.5 degrees. Questions so far with that? Okay. So then, now that I know n, I don't know n, but again, this is isosceles, so I know that these are congruent. So I can go ahead and say then 2n plus my n, which we found was 67.5, equals 180, and then solve from there, and that's how we get our n is 56.25. And you could have, of course, left it as fractions. Questions with that one? Questions on any other ones? Okay. All right, so we're going to go ahead and transition. We actually have a good chunk of time left for you to go and start working on your homework, so I'm going to pass that out to you. Your homework is worksheet 7. Now, take a look at your assignment sheet. What do we have going on next class? Quiz, which means you get back here at the quiz today, if everyone has taken it. So just keep in mind your quiz next class, so that'll be over our last few classes, which was proofs with our isosceles basic equals theorems, and applying that.